Yep, it's just on video recording. Just in the back. Okay, so as we get going, you're going to need your pencil and your daily notes. Is everybody ready to go? Do we have that? Awesome. Let me see thumbs up if you're ready to go. Thumbs up if you're ready to go. Awesome. Okay. So first things first, I want to review what we were talking about last week. Does anybody remember? What were we doing last week? I know that was about a 5-day weekend. Right?
You were looking at shapes and you were looking at the angles.
Yeah, shapes, angles. Connor?
Symmetry.
Yeah, like line symmetry, right? Nice. Okay, so if I was standing here just straight like this, where could you find the line of symmetry on me? Down the middle. Yeah, hypothetically, right? It might not be perfect, but down the middle, right? Could you do one horizontally? No, that wouldn't work. Just down the middle, right? So what about if I put my arm up like this? Am I symmetrical still? No. What do I have to do to change?
Use the other one.
Do my other one up? What about now?
No.
Is this symmetrical?
No.
No, I have to change. Okay, so I have everybody stand up and show me symmetrical. Yep, be symmetrical. You can do whatever you want. You do it on one side, you have to do it on the other one, right? Alright. What do we have? Just lines of symmetry. Ah, I'm liking the line. Lines of symmetry. Nice. Cool. Fun. Okay. Thank you for entertaining me. You can sit down. Are you guys? No. Okay. A question for you. This week we're going to be talking about different types of triangles. So what do we know about triangles already? What do we know about triangles already? Emerson? Yeah. Okay, so triangles have 3 sides.
So do your best to help her, okay?
3 sides. What else do we know already about triangles? Jada?
3 angles,
Oh,
3 vertices, 3 vertices, and 3 angles.
3 angles.
And points. 3 points.
And Connor?
3 vertices, the corners.
Yeah, the corners, 3 vertices and 3 corners. Good. I would add that in with angles, right? Because if it comes to an angle, that's also like what you could call a corner. And it's also a vertice, right? Yeah. Good. Jill, do you want to add anything too?
3 corners.
Yeah, 3 corners. 3 corners, 3 angles, 3 vertices, 3 sides. Good. Okay. So what we're going to be learning in geometry, as we are in right now, is how to classify triangles based on different side lengths and their different angles. Because triangles could have all different kinds of side lengths, right? Some could be longer, some could be shorter. They could all have equal lengths. And we can look at angles in triangles too, right? Not all triangles are going to have the same angles, right? Some triangles might have a larger obtuse angle, right? It could have a right angle, it could have acute angles. So we're going to look at those, okay? That's what we're going to be doing today. We're going to be looking at how to classify triangles by side length and by angle length or measurement, okay? Okay, so to start off, grab your notes in front of you, please. And we have the ones from last week because we didn't use much of the space. So I figured instead of getting out a new piece of paper, we would just use last week's as well. Okay, so on your next blank piece of paper, I want to introduce you to the 3 types of triangles based on side length. Okay? It's 3 types of triangles. Those are the 3 ways that you can classify triangles based on side length. Okay. So here's our first one. You probably have heard of it. We talked about it in class with Mrs. Goody. It's called an equilateral triangle. Anybody heard of that one before?
Yes.
A couple people have. Or maybe an equilateral triangle. Alrighty. So an equilateral triangle, does anybody want to infer what that means before I tell you? Emerson?
All the side, well, it's like the same length.
All the sides are the same length. Anybody else agree? I would agree. Awesome. So I am going to ask you to write this down, okay? So on your next blank piece of your section on your paper, write down equilateral triangle, and then we're going to write the definitions as well, okay? So we have an equilateral triangle. Emerson told us that it has 3 congruent sides. What's congruent mean? What's congruent mean? Think to yourself, where have I heard that before? Julia? The same. Yep. Same size, same shape. Mathematicians just say congruent for another word for equal or the same. So equilateral triangles have 3 sides that are all the same length. Nice. Go ahead and sketch an equilateral triangle next to it. 3 sides that are going to be the same length. Just a sketch, it doesn't have to be perfect, right? Just something to help you remember in your notes as you look back. Okay. Alrighty, this is going to be something that we're going to need to remember, so it's definitely going to be something you need to have written down, okay? Awesome. So 1 down, 2 more to learn. Who still needs more time writing it down? Okay. I'll take a little bit of time. Okay. Awesome. Okay. So the next one we are going to learn is called an isosceles triangle. Everybody say that with me. Isosceles triangle. Let's try it one more time. Isosceles triangle. Awesome. So hopefully you've already heard of this because we've talked about it with Mrs. Giddy, but it's been a while. So an isosceles triangle, does anybody remember? What does that mean? What kind of triangle is an isosceles triangle? Great. Okay, that's a guess. Maybe the sides aren't equal. Connor?
Yeah. Some of them are equal and like one isn't.
Ah, so how many would be equal if one isn't? How many? 2. Yeah, you're right. So an isosceles triangle has 2 congruent sides, or 2 sides that are the same length. All right. Go ahead and write that in your notes as well. That'll be something you need to remember. And then once you have that written in, go ahead and draw a little sketch next to it. Awesome. How are we doing so far on that? Do we still need more time? Good. Awesome. Alrighty. So, good mathematicians, I should remind you, or maybe teach you if you don't know, we use tick marks on congruent sides, okay? So, with an equilateral triangle, how many sides are congruent? Or how many sides are the same? Show me with your fingers. How many sides are congruent? Some twos, some threes, some nones. All right. So with an equilateral triangle, we know that there are 3 congruent sides. So in order to show that you know that there's 3 congruent sides, you add in the tick mark. Just a little line to show that they're congruent. Okay? So with an equilateral triangle, you have 3 tick marks. On an isosceles triangle, there's 2 congruent sides. So you need to make the 2 tick marks on the 2 sides that are the same length. So it would be on this side and this one. Not on that bottom one though, because that's not the same length, is it? Alrighty, and our last one is called a scalene triangle. Let's say that one together. Scalene triangle. Let's say it again. Scalene triangle. Does anybody want to infer how many sides are congruent on a scalene triangle? Even before I tell you, Gavin?
None.
None? What about 1? You guys, I can't trick you. It's 0. You can't have 1 congruent side, can you? You can't have 1 side that's the same. What would it be the same as? Nothing. So it's none. So scalene triangle has no congruent sides. Or no congruent lines. And then go ahead and draw a sketch in there. Scalene can kind of be tricky to draw, but just try to make it so that all 3 lines are different lengths. We'll look at some examples here later. If you want to wait to draw your sketch, that's fine. Okay. All right, how are we doing so far? All right, let's check out a few triangles that I have here. Talk with the partner about this first one here. Triangle A. Partner, based on your notes, what kind of triangle is it?
Equilateral triangle. And it's going to be isosceles.
Why is that?
You don't know that. Maybe she then she's going to put scaling in.
Why would it be called the equilateral?
Before 4th grade, I didn't know that this triangle wasn't
I
didn't even know what triangle had a name.
So Dana, did you share with Jonathan?
A triangle does have a name.
So what makes it an equilateral triangle?
Okay, so let's talk about this one. Share with me what you talked about with your partner. Zanaya and Connor?
All the sides are the same.
Okay, they said all sides are the same. Sophie? All angles are the same. Great.
The sides are three congruent.
The sides are 3 congruent. So Jonathan, what kind of triangle?
Equilateral.
Yes. How many of us agree? Same. Equilateral. All right, here's triangle F.
Scaling.
Check out triangle F. And take a minute to talk it out with your partner. What kind of triangle?
Scaling. That's all. It because none
Talk
of
about it with your partner. Talk about why.
This side is really big. This side is very big. And the bottom is tiny. No,
because the one on the right is slightly bigger.
So you think it's a actually, she made them. Kind of looks like
Yeah,
So what is
scaling.
that called again?
Scaling.
So what happens when they hold on, they are like these?
Interesting. I like all the different conversations that we have. Let's come back together. 5, 4, 3, 2, and 1. Awesome. Alrighty, what do we talk about? What are we thinking? Dylan and Emerson.
We think it's an isosceles because the two ones are not the big one, but the two other ones are equal.
Okay, so you think that there's 2 congruent sides, so you think isosceles. Sophie?
I think it's scaling because if you bend your head a little, then well from the long one is easy to see, but then the bottom is smaller, so then it kind of looks like an cube, but then up here it's really long.
Interesting. So she thinks maybe scaling. Sophie? Sorry, I just talked to Sophie. Gavin and Alex, what do you guys think?
I think it's a scalene because the side on the right is bigger than the side on the left.
Interesting. So what if we don't know if the side's bigger than the other? What can we do as mathematicians? Right?
You can measure it.
We can measure it. Nick?
You could pull one tip from over here to the bottom to the bottom.
We could fold it. I agree. Gavin?
I think it's isosceles. Alex thinks it's scalene. We have 2 different opinions.
So far we could measure it or we could fold it. What should we try first?
Fold it.
Oh my goodness, we're folding it. Okay. So if we folded it, so if we think it's an isosceles triangle, which has 2 sides are the same, it would have a line of symmetry right down the middle, right? So if this side's the same and this side's the same, when we fold it down the middle, it would have a perfect line of symmetry, right? Let's check it out.
That doesn't.
Okay. Sometimes it's hard to tell, so sometimes you have to measure it, sometimes you have to fold it.
I know it.
Okay, so I'm going to put those corners together as perfectly as I can. Fold it. What do we think? I think it's pretty close. I would have to say, right, it's isosceles. So, I think it's isosceles just because those 2 sides are the same length. But what we could do is we could take our ruler and measure it in inches. This is about 4 2/8 on that side. And this side is right about 4 2/8, 4 3/8. So if I measured them differently, we would say what? If I measured them differently, we would say scalene, right?
But yeah.
So ultimately, it's important that we have our tick marks, right? So if we thought that they were the same, and we had tick marks right here and right here, I would know, I could read your paper and say, oh, they think those 2 sides are the same. So what kind of triangle would it be? Isosceles. But if you didn't have your tick mark, I would assume that you thought they were different, right? So then what would you label it? Scalene. But sometimes it's pretty hard to tell. But I would say that I made this triangle so it could have some human error to it. But I tried to make an isosceles triangle. So, yeah. Good debate. I like the questioning. Okay, let's look at this one. Triangle C here. And talk about it with your partner. Okay, just 10, 15 seconds, okay?
You said isosceles. You did say isosceles. Yeah, you really said isosceles.
Because, well,
Yeah, because
it goes all the way down. Well, that one has.
You said isosceles, and then I said
Okay, what do we think?
can't stand by.
Oliver and Jersey. What are you guys thinking?
When she folded the last one, you quickly said,
What kind of triangle? Did you say scalene? Anybody else agree? Anybody else want to debate that? Dylan?
It might be equilateral.
No, I think it is. I think the majority of you are right. It's scalene. This one's easier to tell, right? You can pretty easily tell that this side is not the same length as this side or that side.
I think Dylan said that.
Good. Okay, so let's grab our notes back out, okay? And since we have pretty well covered those three, do you guys feel pretty good about being able to label triangles, either equilateral, isosceles, or scalene?
Yeah.
Let me see with the thumbs up, thumbs to the side, or thumbs down if you're like, we really need to talk about this more. Okay, so I'm seeing some thumbs up, some thumbs to the side. Okay, awesome. Alrighty, well, you can put your thumbs down. We are going to talk about, so we just talked about the three sides of the different kinds of triangles, but now we have to classify them by angles. We haven't looked at angles yet, right? We've been looking at side length. So let's look at the triangle's angles. That was fun to say. Okay, so our first one that we're going to talk about is called a right triangle. Does anybody want to infer what a right triangle is? Do you know? Yeah, a triangle that has one right angle. Awesome. I would agree. So this is something you're going to also need to write down, okay? So go ahead and do that. So Leo tells us that there's one right angle. So here's a question for you. Does a triangle have two right angles? No. Right angle?
She wants this written down today. Wait.
Yeah.
Can we draw a triangle that has two right angles in it? No. We can draw one that has one right angle, right? And then we connect the two sides. So we know there's one right angle. Could it have two, Dylan?
Yes.
What do you think?
Because can I come up there and write it on?
Sure. Explain your thinking.
So you can go.
I like your thinking. So, I like your thinking. But technically, the three angles would be right here, right? We have an acute, right? Because we talked about triangles only can have three angles, right? So it would be acute, acute, and acute. I like this thinking though. So if I try to draw a triangle, another triangle with a right angle, we can start with the one right angle. I feel like never really see. If I drew another right angle, it's not a triangle anymore, is it?
Mm-mm.
So how many right angles can a triangle have?
One.
Nice. So if it even just has one right angle, it will be called a right triangle. Right? Awesome. I like your thinking so far. Okay, so here's the next one. The next one is called an obtuse triangle.
Right, obtuse.
Obtuse triangle. And an obtuse triangle has one obtuse angle.
Task, good job. You have obtuse written. What do we have?
Okay, so an obtuse triangle has one obtuse angle. Could it have more than one obtuse angle?
No.
No.
Well, should I try to draw it? Should I try it out here? So we have an obtuse angle here. There's one obtuse angle. I just drew an angle of an obtuse. And if I was going to make it a triangle, I should make a third line, right? So we see here is an obtuse angle because it's bigger than 90, right? Could it have more than one obtuse angle? What do we think? Aiden, could it have more than one obtuse angle? No, I don't think so. Just like we couldn't fit in more than one right angle, we can only have one obtuse. What kind of other angles can be in an obtuse triangle? Aiden?
I can draw it.
You just want to tell me what kind of other angles could be in the obtuse triangle?
You can make another one with you can make another that's wider.
You can make it wider. Yep, your obtuse angle could be bigger even than mine. I like your thinking. Great.
I see with a straight angle.
Yeah, you see the straight angle on top?
180.
Each side is a straight angle. Technically, right? If it's a straight line. Jaleel? Yeah, I agree. We're seeing the two acute. So if we have one obtuse, the other two are going to be acute. Good. Okay, so do we have that written down so far? At least the obtuse triangle? So if there's one more kind of triangle, does anybody want to guess what kind of triangle it is?
Isosceles.
Gavin?
Acute.
Acute. Based on angles, it would be an acute triangle. Now an acute triangle, this is important about the definition. All angles are acute. Okay, this is important because if this is an obtuse triangle, we see that there's two acute angles in there, but it's not called an acute triangle, it's called an obtuse triangle. Same with the right triangle. There's two acute angles, but it's not an acute triangle, it's a right triangle. So I told you that an acute triangle has to have all acute angles. So what's that gonna look like? We could draw an equilateral triangle where all sides are equal, right? And all three of those angles are acute. That would be an acute triangle. So it's going to be an acute triangle if it doesn't have a right angle and if it doesn't have an obtuse angle.
Oh, yeah, you look like
Got that?
that.
Awesome. Okay, so now that we know we can classify triangles 6 different ways, let's look at a few. Everybody have that written down? Read it up still? Okay. Here's triangle B. What could we label it? Connor? An equilateral? All sides have to be equal for an equilateral triangle. Dylan? Isosceles triangle? I would agree because there's 2 sides that are the same. Gavin?
Isosceles because you have marks on two
Just
sides, but not 3.
Yep. And Julia, what else could we call it? Can you say an acute triangle? Yes. I would agree because all 3 angles are acute, right? So we could say acute isosceles triangle or isosceles acute triangle. There's 2 words that we could use to describe this one. Okay, we're going to go through one more here. Okay, this is triangle D. What can we call that one? Here's my right angle template, just as an example. What 2 words could we use to describe this triangle? Nathan, do you have one of them? Yep, there's a right angle, so it would be called a right triangle. So we could call it a right triangle. What else could we call it? Nick? Scalene. Anybody else agree? I do too. All 3 sides are different lengths, so it would be a right scalene triangle or a scalene right triangle. Does that make sense? Is that a lot of information after you today? Are you feeling okay? Good. I'm glad. We will continue practicing. Tomorrow we're going to be building some triangles of our own. Okay? So with that, we are going to go into small group time. Today we have our Wednesday problem. There's also this packet right here that we were working on last time. We're going to finish that up in individual time. And some people also didn't finish up this symmetry page, the back side. Most of us didn't get to the back side. So that'll be during individual time too. Okay? And other than that, it's just your Wednesday problems during individual time. Otherwise, if you are group 1, Jersey, Chloe, Luis, Nate, Oliver, and Sophie, you're with Mrs. Sire, and you need a pencil. And if you are Connor, Greg, Dylan, Emerson, and Nick, you will start off with me. You also need a pencil, okay? Otherwise, everyone else can start on their individual work. Alrighty? Awesome.
Do we need this for anyone? We're gonna need Buddy, we're gonna need this for anything.
You get Miss Banks. So all we need is a pencil. This is for real.
Pass them out, please.